In this video, we are going to differentiate distance and displacement. By definition, displacement is the change in position of an object. It is a vector quantity. Distance, on the other hand, is defined as the magnitude of the displacement, and it is a scalar quantity. Mathematically, the displacement of an object can be written as delta x equals x sub f minus x sub I. Delta x is the symbol of displacement. The Greek letter delta denotes a change in a physical quantity. X sub I is the initial position, and x sub f is the final position. So let's say, for example, a person walks from one position to another. Let's say that this is the initial position, or x sub I, which let's say 1 meter. And then the final position, or x sub f, is let's say 5 meters. To compute the displacement of the person, we just have to subtract the initial position from the final position. We will use the formula delta x equals x sub f minus x sub I. That means delta x equals 5 meters minus 1 meter, which is equivalent to positive 4 meters. The 4 meters here is the magnitude of the displacement, which is also the distance. The positive sign indicates that the person moves to the right direction or to the east. Remember, displacement is a vector quantity, so its direction is very important. If a displacement, for example, is negative 2 meters, then the negative sign indicates that the direction is to the left or to the west. Please also take note that the magnitude of the displacement is the shortest directed distance between two positions. Do not confuse distance with distance traveled. In physics, they have different meanings or interpretations. Again, distance is defined to be the magnitude of the displacement between two positions. On the other hand, distance traveled is the total path length traveled between two positions. For you to better understand this, let us have an illustration. Let's say, for example, you moved between two positions in the kitchen. One position is the door or entrance, and the other one is near the refrigerator. You are here. Let's say P1 is the position where you are standing, and P2 is the position near the refrigerator. Let's say before you go to where the refrigerator is located, you want to check the food inside the oven, or to check something you cooked, and then walk straight to the ref. If you are asked about your displacement between P1 and P2, then you have to measure the shortest directed distance between these two positions. To illustrate, it will be a line with an arrow, which also indicates your direction. This is your displacement, which is a vector quantity. Its magnitude is the shortest distance between positions 1 and 2. The distance traveled is the total path you took from position 1 to position 2. As you can see here, the distance traveled is greater than the distance between these two positions. So you have to remember, displacement only depends on the initial and final positions, and not on the actual path taken. Let's have another example. Given the table, find the displacements of the following. Letter A, the displacement from position A to C. Letter B, from position B to E. Letter C, from position F to H. And letter D, from position H to D. To answer this problem, we will refer to the given table. The first column shows the points from A to H. The second column shows the indicated positions in meters. We will apply the formula of the displacement, which is delta x equals x sub f minus x sub I. Let's start with letter A. We need to find the displacement from point A to C. So the initial position is 0 meter, and the final position is 4 meters. That means the displacement equals 4 meters minus 0 meter, which is equal to positive 4 meters. The positive sign indicates that the direction of the displacement is to the right. Next, letter B. The initial position is point B or 2 meters and the final position is point E or 7 meters. Then the displacement is equal to 7 meters minus 2 meters or equal to positive 5 meters. For letter C, delta x equals 10 meters minus 10 meters or equal to 0. There is no displacement or change in position for letter C. Lastly, letter D, delta x equals 4 meters minus 10 meters or equal to negative 6 meter. The negative sign indicates that the direction of the displacement is to the left. In the next video, we will compare average speed from average velocity.